Hello everyone, welcome to the Bharat Academy. I am Manoj Thapliyal and today's topic is correlation. Now we start correlation. Now we take the correlation. First, it's a definition. A relation between two variables such that change in one variable results in change of another variable. This correlation is measured by a coefficient which is called coefficient of correlation. Coefficient of correlation. A degree to which the two variables are interrelated is called coefficient of correlation. A degree to which the two variables are interrelated is measured by a coefficient which is called coefficient of correlation. It is denoted by letter small r. Types of correlations. First type is positive correlation. Positive correlation, if the deviation in the two variables are in the same direction, if the changes in both the variables are in same direction, then it is positive correlation. For example, age and height of a child. As age increases, his height also increases. As age increases, his height also increases. Changes in both the variables are in same direction means if both one is increasing, the other is also increasing. If one is decreasing, the other is also decreasing. So this is positive correlation. Now we come to the second one, that is negative correlation. Negative correlation. If the changes in both the variables are in different directions, then it is negative correlation. For example, price and demand of a commodity in market. As price increases, demand decreases. As price increases, the demand decreases. Demand decreases. So this is the example of negative correlation, and if there is no relationship between the variables, so this is called zero correlation. If there is no relation between the variables, then there is no correlation. There is no correlation. Example, weight and IQ. Weight and IQ of a person. Weight is not affected by IQ. So this is the example of correlation does not exist. So this is called no correlation. So these were the types of correlation. There are certain properties of coefficient of correlation. I will discuss it. Properties of coefficient of correlation. Coefficient of correlation. First property is that the coefficient of correlation R always lies between -1 to +1. That is, the coefficient of correlation. The coefficient of correlation R always lies between -1 to +1. This is the first property. Second property, if R is equal to +1, the coefficient of correlation is called positive and perfect. The correlation is called positive and perfect. Positive and perfect. If R equal to -1, then the correlation is called negative is called negative and perfect. Negative and perfect. If R equal to 0, it means there is no correlation. There is no correlation between the variables, between the two variables. Third, the coefficient of correlation. The coefficient of correlation R is independent of change of scale and origin. Change of scale and origin. Let me explain it in a very specific way. If value of R is more than 0.9 or -0.9, so then the correlation is called very high level of correlation. If value of R lies between 0.75 to +0.9, so this is called sufficiently high degree of correlation. If the value of R is lying between 0.6 to 0.75, so this is called moderate degree of correlation. And if value of R is lying from 0.3 to 0.6, so this is there is only a possibility of correlation. But if value of R is less than 0.3 or -0.3, so then it is only possibility, then there is possibly no correlation. But if R equal to 0, it means there is a total absence of correlation. These are all the properties of the coefficient of correlation. Now we come to the different methods to find the correlation. Methods to find correlation. There are various methods of finding the correlation. First one is Pearson's coefficient of correlation. Second one is Spearmann's rank. Spearmann's rank correlation coefficient. And third one is scatter diagram. Now we come to the first one. We take this one, Karl Pearson's coefficient of correlation. If in this case, if x and y are any two variables, if x and y are any two variables, then Karl Pearson's coefficient of correlation is found as R equal to covariance of xy upon under root of variance of x into variance of y, where covariance of xy you can calculate from this formula, 1 upon n summation I varies from 1 to n, xi minus x bar into yi minus y bar. This is the formula to calculate covariance of xy, and variance of x can be calculated by this formula, 1 upon n summation I varies from 1 to n into of xi minus x bar its whole square. Similarly, variance of y, 1 upon n summation I varies from 1 to n yi minus y bar its whole square, where x bar is the mean for x series, summation x upon n, and y bar is summation y upon n. N is the number of observations in each pair. Number of observations in pairs. So these are the formula for covariance, variance of x and variance of y. Now we put all these values of covariance, variance of x and variance of y. So from this equation first you can calculate another formula. Then the coefficient of correlation R will be 1 upon n summation I varies from 1 to n xi minus x bar into yi minus y bar upon variance of x. This is 1 upon n summation I varies from 1 to n xi minus x bar its whole square, 1 upon n summation I varies from 1 to n yi minus y bar its whole square. This 1 upon n you can take it out. This is 1 upon n summation I varies from 1 to n xi minus x bar into yi minus y bar upon 1 upon root n, 1 upon root n, 1 upon root n. This is 1 upon n, and whole you can take it like this, summation I varies from 1 to n xi minus x bar its whole square into summation I varies from 1 to n yi minus y bar its whole square. 1 upon n, 1 upon cancel. So then directly you can calculate Karl Pearson coefficient of correlation from this formula, summation I varies from 1 to n xi minus x bar into yi minus y bar upon under root of summation I varies from 1 to n xi minus x bar its whole square, I varies from 1 to n yi minus y bar its whole square. You can calculate Karl Pearson coefficient of correlation between the two variables x and y directly by this method. There is another method from which you can calculate Karl Pearson coefficient, that is called shortcut method. shortcut method. When x bar and y bar are not integers, means either of these values is in decimal, then coefficient of correlation can be calculated by this formula. R equal to summation dx into dy minus summation dx into dy upon n upon under root of summation dx square minus summation dx its whole square upon n into summation dy square minus summation dy its whole square upon n, where dx is equal to x minus a is the assumed mean for x series, and dy is, this is dx, dy is y minus b, where b is the assumed mean for y series. So from this formula you can calculate Karl-Pearson coefficient if x bar y bar are not integers. Let us take an example based on Karl-Pearson coefficient. The question is, calculate Karl-Pearson coefficient between the marks in English and mathematics from the following data. Data is marks in English 10, 25, 13, 25, 22, 11, 12, 25, 21 and 20, and marks in mathematics are also given 12, 22 and up to 17. So now we have to calculate Karl-Pearson coefficient between the marks in English and marks in maths. So first of all, we form this table. This is x, this is y. Number of observations are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is equal to 10. And total value of x is summation x is 184. And total value of y summation y is 182. So first of all we will calculate their arithmetic mean. X bar summation x upon n 184 by 10. This is 18.4. Similarly y bar mean for y series summation y upon n 182 upon 10. This is 18.2. So now in such type of cases when the data are large, we already take assumed mean for different series. A is the assumed mean for x. Whatever is the value of x bar, you have to take the nearest value of x bar in the series of x, in x series. The 18.4, the x bar is 18.4, the nearest value of 18.4 in x series is, this is 20. So I have taken assumed mean as 20. Similarly B, assumed mean for y series, you can take it nearest value of y bar in y series. So this is 18.2, so nearest value of 18.2 in y series, this is 18. I have taken B as an 18. And now this was x column, this is y, value of y. Now we can calculate dx. Dx is x minus a, x minus assumed mean. Here assumed mean for x series is 20, this is x minus 20. Then dx square, then I have taken dy, dy is y minus b, b is the assumed mean for y series. This is, I have taken this one as 18. The dy will be y minus 18, this is dy square, and then dx into dy. So these are the values of x, these are the value of y, this is dx, x minus a, this is dx, their total dx is minus 16. Similarly I have calculated all the dx squares and their total is 374. Then again I have found dy, y minus 18. This is the series for dy, and summation of dy is 2. Then their squares and their summation of dy square is 128. And now at last we have just multiplied dx and dy. So these are the results for dx and dy, 60, 20 up to 0, and we have added all these. So this is summation dx into dy, this is 118. So now Karl-Pearson coefficient of correlation. This formula is to be applied. R equal to summation dx into dy minus summation dx into summation dy upon n under root of summation dx square minus summation dx its whole square upon n into bracket starts summation dy square minus summation dy its whole square upon n. N is the total observations, those were 10, and we have calculated all these values dx into dy, dx square, dy square. I have put all these values over here. So ultimately, after calculating, I have got r equal to 0.57. So this r is the coefficient of correlation is 0.57 and this is less than 1. So this is the Karl Pearson coefficient of correlation between the marks in English and marks in mathematics. Now we come to the second method to find the coefficient of correlation. That second method is Spearmann's rank correlation coefficient. Rank correlation coefficient. When the data cannot be measured quantitatively but qualitatively, then such as beauty contest or honesty or IQ, where the first is given first rank, best is given first rank, second is given, then another one is given second rank, and so on. In such cases, the coefficient of correlation can be calculated by r equal to when the data cannot be measured quantitatively but qualitatively is possible such as honesty, beauty, and etc. The best is given rank 1, best is given rank 1, next is given rank 2, and so on. In this case, rank correlation coefficient is given by r equal to 1 minus 6 into summation d square upon n into n square minus 1. This is n square, where d is the rank difference, r1 minus r2, rank difference. N is the number of observations in paired value. And one thing you should keep in your mind, that value of r is always lie between -1 to +1. That is very important thing. Now we take the second example based on Spearmann ranks correlation coefficient, and I have taken this example like this. The marks obtained by a student in physics and maths are as follows. Marks in physics, I have taken X. Marks in mathematics, I have taken Y. The marks in physics are given 35, 23, 47, 17 up to 28, and marks in maths are given 30, 33, 45 up to 31. So now calculate the coefficient of correlation of ranks. So for this, coefficient of correlation of ranks means you have to find Spearmann's rank correlation coefficient. Now we form a table for this again. These are the values of X. X means marks in physics, and these are the value of Y. Y means marks in mathematics. So first we find rank in physics and then rank in mathematics. The rank can be calculated. The student who have scored maximum marks in X, the maximum marks is 47, he will be given first rank, and the next is 43, he will be given second, and then after that 35, this is 3, and the last one there are n number of students are 9. The last rank will be your 9. 6 is the minimum marks obtained by a student, this will be given 9 here. Again I will find the rank in Y. Y means rank in mathematics. The student who scored the maximum will get the first rank. Here the maximum marks obtained by the student in mathematics is 49. He will be given rank first. Then the next one Next got 45, he will be given rank second. Then 33 will be given rank third, and so on. We can give ranks to the different scores. And the last one, which is the minimum marks scored by a student, is 4, and number of students were 9th, this will be given 9th rank. So this is the way to find the ranks in two different variables. And now we calculate this D. D is the rank difference, R1 minus R2, rank difference between the variables X and Y. So this is R1, this is R2, so D is R1 minus R2, 3 minus 5 equal to minus 2, 5 minus 3 is equal to 2. Similarly, we can find ranks, 4 minus 4 equal to 0, then form the column for D square, minus 2 its whole square is 4, 2 its whole square is 4, minus 1 is 1, and similarly calculating all D square values, their total summation D square is 12. So now we calculate the Spearmann's rank correlation coefficient between the marks in physics and marks in mathematics. The formula was capital R equal to 1 minus 6 into summation D square upon N into N square minus 1. N means number of students, number of persons, N equal to 9. So I have put all these values here. 6 into summation D square was 12, N was 9, 9, N square, 9 square, 81 minus 1. This 12 into 6, this is 72, 9 into 80, and this is after cancellation, this is 1 minus 1 upon 10. So ultimately, value of capital R is 0.9, which is less than 1. So this is your rank correlation, this is your Spearmann's rank correlation coefficient between marks in physics and marks in mathematics. Now it's a third method of finding the correlation, that is a scatter diagram. It is a graphical method. It is a graphical method of showing correlation between the two variables. Now if we plot the different points in xy plane, if all the plotted points are along the straight line from lower left hand corner to the upper right hand corner, so this is called perfect positive correlation. If all the plotted points are lying on a straight line from upper left hand corner to the lower right hand corner, then this will be perfect negative correlation. If the plotted points fall in the bands from lower left hand corner to upper right hand corner, so that shows the positive correlation between the two variables x and y. If the plotted points fall in bands from upper left hand corner to lower right hand corner, it will show negative correlation. If all the plotted points lie in a scattered way in the xy plane, then it shows there is no correlation between the variables x and y. Now the lecture is over. If you find it interesting and helpful, please like it and subscribe my channel.